Thank you for digging into that specific SQL example. And it reminds me of something else that came up in our research, which blew my mind and requires so much nuance to get right, is that we read about self-healing data pipelines through these kinds of agentic workflows that you have. So this is autonomous pipeline optimization and that allows self-healing
Hmm.
without human orchestration. So how does that kind of system work? Obviously, without spilling, too much proprietary sauce for our audience, but how does that work in a way that prevents hallucinations or divergent interpretations from cascading through the system?
Yeah, it's a great question. I think, I think it's easiest described with an example, right? So let's take a data pipeline. Most data pipelines are one of two ways, right? You have some sort of a drag and drop interface, which you drag and drop an ETL, and then you create some sort of data pipeline. But usually, it's a part of a larger structure, and maybe written in a deep, in a form of in dbt or some sort of airflow. Let's pick Spark, for example. Spark technology writes a data pipeline. Now Spark in the end is code, right? And so let's assume that you have some piece of code written in Spark, which is representative of your data pipeline. Pick data from somewhere, aggregate it, make some joins, and dump it to a different place. Now, what will end up happening is that this Spark code is being executed often onto your cluster, right? Now, let's take one step back. Let's look at how is something like agentic coding working these days. So we can pick up, let's say, Visual Studio Code or C Line or Cursor or something like that, and we can ask it to generate code. Let's say we create a small website, right, or a stock follower, anything. And so it's going to generate a lot of code, and it's going to use your laptop or your Mac OS as the runtime because it's going to say npm run, right? It's going to run something, and it's going to use your laptop and its CPU and its runtime to essentially show up a browser. And then you say, okay, I like it. The design is great. Everything is okay. Now I'm going to deploy it. And then you create the deployment out of it and you put it on a server where that website uses the resources or the runtime of that server, right? Now just imagine a data pipeline. The data pipelines in bigger companies are not executed on laptops and servers. These are usually executed on clusters of machines, right? So whether it's a Hadoop cluster or a Trino cluster or your Kubernetes cluster, and then you're running jobs and you're executing your data pipelines on it. Now, what we can do is, let's say you get an alert from your data pipeline which says that, hey, there's some issue and it requires a small fix. Now, before AI, somebody had to, file a bug report, and you had to clone this code, and the person who knows about what this code does and what needs to happen can actually make the fix, put it into a CI, and then go deploy it on the cluster. Right? That's how it's going to work. Now, in this day and age, what you can also do is that you can have an agent detect if there is a log entry which shows some sort of an anomaly or something is not right. You can actually clone the code automatically, provide the context of this error, provide the metadata of what this data, this pipeline is touching through the Xlake engine, saying which table, how many columns, what data type. And the AI can actually then just rewrite the Spark code. And then you can then go ahead and deploy it back into the execution engine, which is the cluster, right? Theoretically, all of this is possible. And because we know that AI can generate great code, especially with Gemini 3, almost one shot, most 90% of what you want to do. And then if you automate the rest of it, which is the metadata, context, how do you deploy it into the cluster, then you can imagine an agent which can actually self-heal, right? And that's somewhat the path which we have chosen is, how do you provide, number one, AI context about where's the code, what is the pipeline, what is the metadata, and what are the errors which are happening, and then attempt if the AI can actually fix the code or the pipeline by itself. Now, not everything can be fixed. If you have some proprietary Informatica pipeline, HVR pipeline, some Oracle standard stored procedure doing it, not so easy. But more and more, especially with AI, because of code generation, I feel is one of the biggest applications which we'll see, right? It is probably number one in terms of the potential. because the code can express a lot more than anything else.
For
So,
sure. And you
yeah,
can know if it works or not.
exactly. And so more and more we feel that data pipelines are going to shift from drag and drop interfaces to code, because now it's as easy, it's maybe easier to generate code than actually drag and draw pipelines. And so as more and more data pipelines become code, then it's easier to also mutate that code through AI when you have an error. So all you need is something which gives you the context of your entire data lake. What are the errors happening? What are the issues happening? And then essentially have a pipeline which kind of feeds it. So that's the part to auto remediation. Now, I won't claim that we can auto remediate everything, but if most of the factors are right, hey, you have a code based pipeline and it's largely it's version controlled and it's Spark or it's SQL or something, then it is entirely possible to attempt some of these things.